Today we're starting recursion. Recursion is methods that call themselves. Let's look at this first example here. We have public class main, and we have we're going to make a recursion 3 object, and we're going to go test.run, and we're going to send run 1. So we send 1 to this parameter right here, and on what we call the stack, we have a value of 1 for x. So x is equal to 1 first. And then it prints out 1. Print line, actually. So we have 1 printed. And then it says if x is less than 5, x is less than 5, it'll call itself. It'll send x plus 1 to the parameter. So it sends 2 to the parameter. So now x is 2. And on the next line, it prints 2. Then it sends 3. Then it sends 4. And then let's see. Let's see. X has 4. If x is less than 5, that's true. It's going to send 5. So 5 goes to this, and then it prints 5, and then it says if x is less than 5, no, 5 is equal to 5. So then this recursion stops, and we have 1 through 5 printed out. Actually, it's on the next line, so it's a print line. So 2, 3, 4, 5, like that rather. Let's look at the next example. Pretty much the same thing. We're going to send 1 to this method right here. So x is equal to 1. But it doesn't print it right away. Now it says if x is less than 5, call it again. So x becomes 2 in the next one, and then 3, and then 4. Then when it's 4 is less than 5, it sends 5. But it says if x is less than 5, it'll call itself, well, 5 is equal to 5. This is called the base case, by the way. This is going to allow the recursion to stop. And then, well, now we're going to go, we're at the stack here down at the bottom, and now we're going to work our way back up. So we're at the point where x is 5, and it prints out 5. So prints out 5. That one is done. So that run of the method is done. And then now 4 left off at this spot right here because it sent 5. So it left off here. Now it's gonna finish this iteration of the method, and it's gonna print 4. And then it finishes this iteration and 3, and then 2, and then 1. So in this case, if you switch the print and the if statement, it prints the numbers in reverse order. Same thing, we're going to send 1 here, and then we're going to call it self, and then 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 call it self. See, there's no base for this to, there's no reason for this to stop. So what we get is a stack overflow, which means you start getting hundreds and hundreds and thousands and millions of iterations of this, and it just stack kind of overflows, and the program crashes. It's like having an infinite loop, except instead of a loop, it's an infinite recursion. You have what's called a stack overflow. Public class main, do while test equals new do while test run, public void run, there it is. Int x equals 0 do. So keep going while x is less than 10, and it prints out the 1 through 10. And the reason I typed this up and demonstrated is that this is a do while loop, and we could do the exact same thing with recursion. So when we practice all this recursion, we're not saying recursion is the only way to print out the numbers 1 through 10. There's lots of ways to print out the numbers 1 through 10. Recursion just happens to be one of those. On this next one, we have recursion 1 test equals new recursion 1. System out print line tests fun. So we're going to print some value is going to be returned here. And we already are showing that what's returned is 9. Now we're sending 5 to y. So y is 5. So if y is less than or equal to 1, return 1. So we're not returning 1. Else return fun y minus 2. So in this iteration, keep in mind y is 5. And we're going to wait for a return here. We're going to call this, but we're sending 3. And y is still greater than 1. So we're still going to do this. We're going to return, and we're going to have a return here, but we're going to send 1 to the method. So now y is equal to 1, so it returns 1 back to where it came from. And then now we got to finish this iteration right here. Returns 4 back to the first time it was called. And then finally what's returned as a result is 4 plus 5 is 9. Public stack void recursion 1 test test, fun, and send 4 and 3. So x gets 4, y gets 3. And if y is less than 1, we'll return x. Otherwise, we're going to call fun again and add that to x. So we're going to add to 4, and we're going to wait for this return right here. Now what we're sending is x and y minus 2. So we're sending 4 again, but we're sending now y minus 2, which is 1. So if y is less than 1, y is not less than 1, y is equal to 1. So we're going to have this plus 4 right here, and we're going to still send x and y minus 2. So we're sending 4 again, and 1 minus 2. Now we're sending negative 1. But now y is less than 1. So we're sending 4 and negative 1, but now y is less than 1, so we're returning the x value. We're returning 4. 4 plus 4 is 8. We return 8, and 8 plus 4 is 12. Here we have recursion 1 test equals new recursion 1. We're going to print out test.fun44, and apparently we want the answer. The answer is going to be 16. So we're going to send 4 to x and 4 to y. X is not 0, so we're not returning x. We're going to return x, which is 4 plus, and then we're going to call fun. So we're going to wait for a value. Now we're going to send y minus 1 to x. So we're going to send 3 to x, and we're going to send x to y. X is 4, so y gets 4 again. X is not 0, so we go 3 plus, wait for a return. We're going to take y minus 1, send that to x, and we're going to send x to y, which is 3. So here we have x is not 0. We have 3 plus a return value. We're going to go y minus 1 and send that to x. We're going to send x to y, which is 3. So here we have 2 plus something. Now we're going to do the same thing. Y, that's 2. We're going to send x to y. That's 2. So we have 2 plus something. We're going to go y minus 1 is 1, and we're going to send 2 to y. See, we're sending x to y. And we're going to go 1 plus something. Then y minus 1 is 1, and we're going to send x to y, which is 1. So x is still not equal to 0. That's 1 plus something. And finally, here we go. We're going to go 0, 1. Now x is equal to 0, so we're going to return x. We're going to return 0, which is 1. There's 2. There's 4. There's 6. There's 9. There's 12, and that's where we get the value 16 finally sent all the way back up to the top. Have the students try these too. If you're watching the video, I would try, just give this a try and see if you can come up with the answer. That's why I don't have the answer off to the side. So give the output. Pi program, static, system print, number 4 and 5. So x and y. So x gets 4, y gets 5. If x is less than 1, it's not, then return, we're going to go 4 plus 5 plus, wait for a return. Now we're going to reduce x by 1, and we're going to keep y 5. So we go 3 plus 5 plus a return value. Now we're waiting for x to be less than 1. So we go 2, 5. 2 plus 5 plus something. What happens when we send 1? 1, 5. Well, when we send 1, x is not less than 1. So we're going to go one more time with this. We're going to go 1 plus 5 plus wait for a return value. Now, when x does get less than 1, when x is 0, then we're going to return 1. So 1 goes back here. 5 plus 1 is 7. 9, 14. 19, I think that's a 3. 19, 22. 9 and 22. I get an answer of 31. Here we're going to send 4 and 5. So we're going to send 4 and 5. That's on the top of the stack there. If x is less than 1, return 1. All right, so that's not happening. So here we have 4 plus 5 plus, and we're going to wait for a return. Now we're going to send x gets y minus 1. y gets x minus 2. So x is not less than 1. We got 4 plus 2 plus something. X gets y minus 1, and y gets x minus 2, which is 2. So x is not less than 1 yet. It's equal to 1. So we get 1 plus 2 plus something. X gets y minus 1. X gets y minus 1. And y gets x minus 2, which is negative 1. So x is still not less than 1. So we have 1 plus negative 1 plus something. Now, x gets y minus 1. Is that going to be negative 3? And y gets x minus 2, which is negative 1. Now, finally, x is less than negative 3, so we're going to return 1. So that's 0 plus 1 is 1. 2 plus 1, that's going to be 4. That's 10, 15. I'm getting 19 on this one. Have the students try this one. All right, let's give this a try. We got x and y, 5 and 6. We're going to start out with 5 and 6. Same thing, x less than 1. Now we're going to go 5 plus 6 plus. We're going to wait for a return. But x gets x plus 2, which is 7. Y gets y minus 1, which is 5. And if x is less than 1, return 1. So we do 7 plus 5 plus something. Well, now we're going to send 9 and 4. But now I've noticed something. We're waiting for x to be less than 1, and x is just going to get bigger and bigger and bigger. So this one is going to be a stack overflow. Let's try this one. We're going to send 3 to x. So we have an x value, which is 3. If x is less than 1, return 1. Now we're going to return number. Oh, it calls. So we're going to wait for a value right here. We're going to wait for it. And x goes to 2, which we're going to wait for this value right here. Then x goes to 1, and we're going to wait for a value here. Finally, x gets 0, and we return 1. But now we have to finish plus number x minus 1. Now it sends 0, so we're going to wait for this value. We're waiting right here, waiting for this value, but we've sent 0. So on this iteration, we've sent 0, and x is already less than 1, so it's going to return 1. Then it comes back. Now this value gets 2, and we got to finish out this iteration. So now this is waiting. It sends 1, which ended up, when it sends 1, you end up with 1 plus 1. So this gets 2. That goes to 4 plus. And now we're sending 2 right here. But we already know what happens when we send 2. We get 2 plus 2, which is 4. So I don't have to redo that. So I should get a value of 8 on this. What does the method tricky 30 return? So we're going to send 30 to n. If n is greater than 2, return. So let's go. N is 30. Return 3 plus, and then we're going to send 15. Then we're going to go 3 plus and send 15 divided by 2 is 7.5. So it is 7. So we have 3 plus. This is going to be if n is greater than 2. All right. So 7 divided by 2 is 3. So 3 plus something. And then 3 divided by 2 is 1. So now we're going to return 5. So when we send, when we send 1, it'll return 5. So 8, 11, 14, this should be 17. What does the method return? Mystery 4, 3. 4, 3. So let's keep track of x and y. 4 and 3. If y is equal to 1, y is not 1, it's going to return x. Else return x. 4 times something. And it sends x to x and y minus 1 to y. If y is equal to 1, y is not 1. Ooh, if we're multiplying, this could get really big. We're sending 4 to x, and now we're sending 1 to y. Good thing this ended early because these numbers could get big. We're going to return 4 back to this one now that y is 1. That's 16, and what it eventually returns is 64.